Everyone. So happy to be here to kick off session 3 with you. I'm not Deepak, as you can see, but he did ask me to come here in his place. My name's Adam Kaplan. I'm a senior staff engineer at LinkedIn. I work on Agents platform, which is part of Core AI, where I work with Deepak on the future of autonomous agents. So just a quick sidebar, why LinkedIn? Why am I here? LinkedIn's vision is to create economic opportunity for every member of the global workforce, and we believe that we can't do this at this point without agents to help workers unlock value by getting their work done more efficiently. So I promise this is not a producty thing, but bear with me for a minute. There is a point. Late last year, we launched something called Hiring Assistant, which is a multi-agent product that's targeted toward recruiters, so probably nobody here has used it. This is not the target demographic. But this is a system which uses 4 agents with a supervisor agent, kind of a common pattern. I know everyone here is probably familiar with it because I saw that in the previous talks, hands were raised. Like pretty much everyone has designed a multi-agent system here. Well, as pre-work, we start out with a preference model that's constructed by analyzing the recruiter's decisions and actions made in past projects and current projects so that the agents can be personalized to a particular recruiter. And so these 4 agents here, the first intake agent, that's helping the recruiter get through the workflow of creating these roles and job descriptions. The sourcing agent goes and finds a huge list of candidates. The evaluation agent helps you hone in helps the recruiter hone in on the best candidates. An outreach agent actually initiates that initial communication to the candidates in a way that's personalized to the candidate and the recruiter. So this system is supported by a deep ecosystem of tech stack that consists of like open source and sort of where there are gaps in the open source ecosystem, some home-rolled technologies. So why am I talking about this, besides to show that we're doing cool stuff? Hiring Agent was shipped in October. That's a multi-agent system delivering value to our recruiter customers for months now, and the reviews are that they're getting significant positive impact. So when we talk about the frontier, this is the frontier stage. Multi-agent systems certainly are the frontier, but I feel like this is like a crashing wave at this point, not a cresting wave. So when we're standing on this frontier and looking forward, I mix my metaphors here around the curve, but when we're looking forward, we see autonomous agents rising in importance. And these 2 things are linked, right? And I'll get to some of that in a moment. So what is an autonomous agent, at least by my definition of an autonomous agent, is an agent that starts to take in multiple signals from its environment and use those signals along with its memory to orient itself. And then we go into the typical like React loop that you can see there on the right side, reason about the next best action, take that action with a tool, incorporate the feedback, and on and on. So it's a subtle difference, but very impactful by taking in multiple signals. We're going to get into a bunch of interesting problems that I want to talk to you about here. The first one is memory. Okay, so again, this is a typical memory stack that you might end up with if you're designing an agent within a multi-agent system or not today. You have roughly 3 tiers of memory. The first is your in-session memory. This is your active conversation, messages that the user sent, what you sent to the message, tool calls you made, results from those tool calls. Very high resolution. The second tier, when you have too much of that conversation, is summarizing that history along some axis of classification. If it's like a ChatGPT where you click new chat each time, then there's your classification right there. You summarize each of those. And now you have, in your context, you have the broad strokes of what you've done and the learnings and takeaways from that. When you have too many tasks that have been summarized, now we move back one step further, break everything down into primitives, facts, phrases, shove them in some retrieval system, EBR, or if you want to be fancy, maybe something that's powered by an agent, or maybe a combination of those 2, and use it for RAG. So with an autonomous agent, it starts to look a little bit more like this. if you can take in multiple signals at once, and I'm talking about a specific agent here. I'm not talking about everyone's individual agent, right? So those signals can come from two different users. So now we end up with these two isolated memory stacks. They're isolated because people expect that. There's a certain lack of trust we all have right now, everyone in the world, with agents. And part of that, part of getting around that involves us assuring people that when they say something to their agent, it's not going to be repeated back to another person or otherwise, leaked across boundaries. But this presents a pretty big problem, and it was touched on in some of the morning session 1 talks. Take a straw example. If we have an autonomous agent named Evie who is working with a user named, let's say, Jane, to plan an event, it's an event coordinator agent, and it's working on setting up all the logistics for something like this conference. And then we have another person, John, who's aware of that whole setup and reaches out to Evie and tells that agent, hey, we're going to need 10 more rooms or something. What is that agent supposed to do? In the current scenario, the naive context, it's probably going to start to reach out to the hotel, let's say, I mean, if that was possible. And that can cause confusion because now you have not one single point of contact for that, making those decisions. So the way around that is to introduce another type of knowledge, which I'll call here common knowledge, for that agent, within that agent, where it's aware of at least what it's doing in other contexts, if not just enough information so that Evie would know that it shouldn't take an action. It should probably tell Jane that there was this change, and maybe we incorporate that information into the main task loop instead of forking somewhere and causing chaos. So how do you get things into common memory? We're working on it. That's about all I can say there. It's a big one to solve because the concerns that you would have with this are very broad. There's trust concerns between those two users. If you're in a company, which is likely where this would be happening, there's regulatory concerns about data being shared, like DMCA and things like that come into effect. There's policy concerns from the enterprise administrators. Lots of things that need to be worked through. And then there's the basic human expectations of what is appropriate to be shared. But I think we can solve this. And the reason I think we can solve this, and first of all, we need to solve this, because if we don't solve this, our agents are stuck in boxes, and it's going to be a pretty lame next 2 years. The reason I think that we can solve this is because human memory, we usually experience human memory through language. There's actions that you take, but I think that's not really the analogy we use, because if somebody forgets how to use a spoon, we consider that a debilitating illness, right? That's not what we're talking about here. We're talking about how people make decisions about what memory is appropriate of their memory is appropriate to use in what context, and how to let it decay, in these tiers, how to let it decay in this sort of expected fashion. If you can't remember what type of pencil you used to take notes 2 years ago, nobody thinks that's a problem. It's a feature of the system. So because we can express those limitations and boundaries in language, I think that starts to look a little bit more like the reasoning problem. Once we were able to express reasoning through language, we could attack it with the models. So that's something that I'd like to see happen here, and it's pretty important for us. The next place that I want to go is to talk about our modular agentic architecture and how it's essentially come together in practice. So we start here with our sort of typical React loop that I showed in the beginning, with an additional box here in the top labeled tool discovery. So the tool discovery is meant to help the autonomous agent explore its environment. So with specialized agents, you tend to have not much agency. There's a few tools that they have. There's a sort of predefined workflow that they're operating in with set decision points, and they make decisions, the LM's making the decisions, but where it goes is kind of controlled. When you have the more autonomous agent, it has a larger set of tools, available to it, just by definition, because you're doing the work of multiple smaller agents. 2 years ago, I think maybe 10 tools was the guidance that you can realistically put into an LLM. Last year was 30, this year with O3, we're at 100 for that particular model. Great progress, 10x in a year and a half or so. But the amount of tools is 1,000x since then. And we see things like MCP on the scene, providing this fabric that allows existing APIs to communicate their capabilities as tools to LLMs more efficiently than ever before. So there is an explosion of tools. Tool discovery is going to be with us for some time now, for some time yet. Yeah, I'll leave it there. Now, ACT, tool calling. When you have the more autonomous agent where you're not planning every single action that the agent takes, you will quickly realize that there are two classes of tools. Idempotent tools like knowledge retrieval that are fine, you just use them. That's maybe like 10 or 20% of your tools. And the other 80% are destructive, potentially destructive tools. Sending an email, they're all like communication-y, right? Sending an email, committing code is communication. Sharing a doc, commenting on a document, or like planning an event. So these things, because they start looking like communication, we found that we have to treat them the same way we treat messages sent to the user. So we have safety validations on the parameters that go into the tool to make sure that they're not hallucinated, that they're appropriate, and things like that. Similarly, when we get feedback back from the tool, we don't just stuff it in the context. We first have to do semantic jailbreaking and other checks, static and model checks, because once data goes into the context, it becomes very difficult to take it out. You might get saved by, if you're in Azure, by their content filter, for example. But then what do? It's hard to back off an agent that's working on a long-running task to get back to a state where you can actually like execute safely, because there might have been tool calls that happened in the middle that you can't forget. So both of the feedbacks from the tool safety and the jailbreak are communicated, both of the validation feedbacks are communicated as tool feedback so that the autonomous agent can reason about what happened and make a decision. For example, maybe it goes and tries to find another tool, or maybe it changes the parameters it uses, comes up with a novel way to reach a conclusion, or gives up. And the last thing that I'll talk about here that we found becomes very important is that there is not enough GPU, right? Okay, so reasoning models are great, and you can make some amazing experiences quickly with them, but you can't scale them. So what we found is that there are a pretty significant amount of user requests that come in, which can be satisfied by the existing context. You don't need tool calls. You're like if I ask the agent what its name was, or whatever, something like that, which it just needs to reference in the current context and respond back in a coherent way. We use a completion model for that. So by doing complexity classification, we can move work off of the slow, expensive reasoning models onto the faster, lower latency completion models, and let our reasoning models spend more time on the harder problems. So in essence, what I want to just leave you all with is that main takeaway that I've had after working towards autonomous agents for the past 2 years now is that if you set out to bend the human expectations in the human world to the agentic world, you're not going to succeed. The way forward here is to take the agents and take the systems that we're building and adapt them to the human shape. This world is designed for humans. Everything about it, the expectations, the communications, the way we work, is designed for humans, and that's what we adapt to. So, I mean, my last minute, something that I've been thinking about recently around trust is like people expect the model to be perfect, never leak info. Okay, when you hire someone, you onboard them into your organization and give them the keys, and why do you expect them not to exfiltrate all your data? If we can understand the behavioral psychology of that and figure out how to adapt our agents to that, to build the infrastructure for them to conform to that, I think we're going to be very successful. So thank you. That's all I have for you.